lecture 7 of the PN junction. So now we are going to move from the material property, let's say the silicon electron hole density or the mobility or the diffusion coefficient. We discuss all the basics of the material, the silicon material. Now we are going to move to the next step, which is to build the devices out of the silicon. So those will be the building block for your circuits eventually. So now we are going to start with the PN junction first. And this is a reference chapter in the textbook, and also Professor Asif Khan's lecture video. So let's review this. We have seen this slide before, the circuit elements for the integrated circuits. And we talk about the metals in lecture 2. This is to build the interconnect. Essentially, it's a resistor. And then we will also have the element like capacitor, which we will talk about later, maybe lecture 8. And then also the diode and PN diode. Essentially, is what we are going to discuss in this lecture 7. It's built out of a PN junction using the silicon. And in the last 2 or 3 lectures, we talk about the doping in the semiconductor. We have the P-type doping, N-type doping. And then we are going to use those 2 types of doping to build this junction for the PN junction. So that's why we need to discuss the P-type and N-type first. Now we are going to combine those 2 to make a junction. This is what we are going to discuss today. And then later lectures, we are going to move to more complicated structure like MOSFET. And if you run the source and drain here, then we will get MOSFET. We will discuss that in more details later. But let's say for the MOSFET and the MOSFET, it's based on the MOS structure, the metal oxide semiconductor. So what we have here is, for example, the silicon substrate, the wafer, the pizza, you remember? So that is the substrate. So it also called the body contact. And then we can grow the silicon dioxide at the top surface of the silicon. And then on top of that, then you can deposit a piece of metal as the electrode. So essentially you have the MOS structure here. And this structure essentially is a capacitor. And if you want to make a transistor, then you need to make some modification to this MOS capacitor. So the modification we have here is to add those 2 regions. So still here you have MOS structure, but to the left and right, we need to heavily dope the silicon. For example, with N+ doping. Plus means heavily dope. Okay. Typically you have N-type doping, but if you heavily dope, that means like 10 to the power 18, 5 times 10 to the power 18, then it's heavily doped, so it's N+. And the substrate, let's say, can be P-type, so it's a P-type body. So if you do this kind of modification, then you will get this MOSFET, MOS, field effect transistor. And in this case, it's an N-type MOS. This is N-type. So you need to notice that if your body is P-type, the transistor is called N-type transistor. This is a little bit confusing or counterintuitive. But this is, we will see later why this is N-type MOSFET. So let's talk about MOSFET from some very high level, let's say, analogy here. So MOSFET, you can think is a switch Okay, it's like a light switch here. So this switch controls this light bulb. So basically, if you have current flow, the light bulb, then you are going to light up, right? And then this is the switch. So then the MOSFET, if you use a circuit symbol for that, it will like this switch. It will have two terminals to pass the current or block the current, and then it has a control terminal. So this control terminal is called the gate. And then here, this is called the drain, this is called the source. So those three terminals here will be the MOSFET. Essentially, you control the current flow or block the current flow here. Or you can make another analogy here, right? If you have faucet here, then let's say where is the gate, where is the source and the drain. Right? You can imagine that this, of course, this is the gate, and then you have a drain here and the source here. So you have the current flow, and then you can control the current flow on or off. So that exactly the same function as the MOSFET. So it's a switch, essentially. And then if you draw the 3D cartoon figure for the MOSFET structure, you will see something like this. So here, this is the substrate, and this is either N-type or P-type. If it's N-type N-type MOSFET, then the substrate is P-type. So let's do that. So this is if you dope your substrate with P-type doping, but then you need to make this source and drain region N-type doping, N plus actually, heavily doped. So that means in the fabrication process, you are going to first dope the substrate with some P-type dopant, for example, boron. And then you need to define two regions. One is called source, one is called drain. And in those two regions, locally, you are going to dope with N-type doping. For example, your arsenic. Only to those two regions, those two regions. And then, between the source and drain, you are going to grow the oxide. And on top of the oxide, you will have the metal, like the gate. But we discussed before, you can also use either metal or heavily doped silicon. Actually, it's polycrystalline silicon as a gate. Because doped silicon is kind of conductive. So you can also use that as a gate electrode. So this is the structure of the MOSFET. And in the circuit symbol, so this is a simple circuit symbol for this N-type MOSFET. So it's similar like what you have here. You have a gate, and then you have a capacitor here. So that is this MOS capacitor. And then you have the drain and source. Or if you look at the cross-sectional view of this one, if you cut in cross-section, then you will see this kind of structure. Then later you will see that we control the gate voltage here, then we can control the current. So for the N-type MOS, if you have large voltage, large positive voltage, then you will turn on, you will have current. If you have small voltage, then the current will be zero, close to zero. Then it will be off. So it's like a switch on and off. Any question? So here, question?
Is the oxide too thick?
This cartoon is not in scale. So the oxide actually is very thin, like 1 or 2 nanometer. Yeah. It's very thin, this oxide. This is not to scale. This is very thin actually. So we will discuss more details about MOSFET in a later lecture. But before that, what we want to discuss is the PN junction. Why PN junction? Because if you look at the substrate of the silicon, you will have those PN junction here. Because the substrate is p-type, and then you have N plus doping here, N plus doping here. So here there is a junction here. And here also you have the junction. So let's say your source drain and this substrate is for the body. So from the body to the source terminal you will see the PN junction. From the body to the drain terminal you will also see the PN junction. So we need to understand the PN junction first before we talk about the MOSFET. So that's the motivation here to discuss the PN junction first. I think time is up for today, so we are going to stop here.